Let's solve this first missing positive. Then given would be some unsorted integer array nums this, and we need to return the smallest positive integer that is not present in nums. Before moving forward, yes, we all are aware um, this positive number, it's gonna start from 1, and it could be 2n or something like that, but in this context its number is 4, and the max it can go is 1 to 5. I'm not gonna go in detail because I think we all are aware of that. The main optimal approach, or it comes from actually the constraints being it has a type and complexity of on, the required one, and space complexity is actually O1. But if it did not had been O1, then we could use some create a new hash set, get all those elements in there, and then search through all these numbers in a different paths or something like that. But this creates a problem. We need to find a constant space algorithm, and that's actually the only possibility is going to be the manipulating the index itself, right? And so for this algorithm, what we're gonna do is, for each element we're gonna place at certain index, and the certain index is gonna be decided by, suppose it had been a normal something like continuous elements, where it would have been something like 1 2 3 4, then we know that this one element, this element, it's at index 0, and similarly for others. So we can say that n element with value n should have at index n minus 1, right? This is the bind that we're going to follow to get into find this approach. Okay, so coming to the next, and we can do this in the sense that if we take this input array directly, then we know that this 3 is gonna be, let's take that for example here. So we know that this 3 is gonna be at here, that is second index, and we're not sure about this one, where we're gonna put it. So let's, for the time being, let's swap that to with this element. So now we can say that this is the correct index for this element, right? And similarly we would do for 4, that's going to be minus 1 1 and 3. It would be swapped with this element, it would be 4 again. We can also see that this 1 needs to also to be at 0th index, that is 1 minus 1 3 and 4. So now if we somehow get something like this, then we can directly see that this index is missing. I mean it so in this case it's minus 1. In actual case it might be any number apart from 2. So in that case we know that the number 2 is missing. So in next pass we can directly get that something like that. So to do this, to write an algorithm for this, we can directly see that for each index it has to be a while loop, because we are going to replace after swapping. It could be a multiple swap required for a particular index, right, as well. So something like, I will start the code first. So first I will get the length of this input array, and the first thing I'm gonna do is I'm gonna get the index 0, and I'm gonna loop through till this whole given array. And what we're gonna do is we're gonna check the correct index on this nums actually at this index should have been, and that would be minus 1. So that is definitely directly we can link to this one, where particular number of any particular element of any array, it has to be at n minus 1 index. So that's how this is this means. Okay, so okay, now other thing is, uh, then becomes the, the next part is to loop, or when are we gonna iterate over the next element. And that's the thing. I mean, and since we know that the numbers are gonna be 1 to 4 itself, then it could be, we can have something like, if nums I, this number is, in the place of this number, that is this, and we already have the length of the array there. If it lies in this, then we would basically swap that, and by swapping, I mean, if we would have something like the nums I with this nums of, let's say, correct index, we're gonna swap this to the nums of, I'm gonna copy paste it, it's, yeah, and it's gonna swap this with this current element of this, to this current index and the current element. And we also need to, it there might be a case like even in here, right? If we are kind of running through initial entry, and later we need to skip the 3 because this is already there, and with this current algorithm it's gonna be never ending loop. So we need to add one more check where if this number is not equal to this correct index, and this, and there is the the other side of this equation is going to be either the number at negative, or either the number greater than the the length of the array itself. We would not be, we are not going to entertain those, because we only want this array in this format, because the answer lies in it only. And so in that case we would just increment the counter, and should so this whole code will give us this list. Now coming back to the second pass, where we can look through this this new array, or I think it's modified the nums itself. We can check something like, if the nums of I, if this number is it's not equal to the at the index of it plus 1, that is if the 0th element is not equal to 1, we would directly return that value that this item is missing. And if this therefore possible that if the array itself becomes something like 1, 2, and 3, and 4, then we know that the answer is going to be 5, because all those elements are already satisfied, and all those smallest integers, all those integers are in the array itself. So in that case, we need to return the n+1 approach. Let's run this up and let's submit.